Okay, we're going to look at exercise 18B. We're going to look at question 6. Okay, so we've got a sine rule question, essentially. We're given that AB is a tower 60 meters high, so AB is 60 meters high, and it's on top of the hill. We don't know what the height of the hill is. The magnitude of ACO is 49, so this angle, this whole angle, ACO, is 49 degrees. And the magnitude of BCO, which is the small angle, is given by 37 degrees. Okay, we're trying to find the magnitude of angles ACB. So angle ACB, okay, ACB is talking about the angle in between here. Okay, now since the total angle is 49 and BCO takes up 37, ACB is just a subtraction of 49 and 37. So we get 49 minus 37, we get 12. Okay, so it's 12 degrees. We want to find the angle CBO. Okay, CBO. So if I draw CBO, we know that's 9 degrees. We know that's 37. So CBO, that angle, must be 180 minus 37 minus 90, because we know the angles inside a triangle sum up to 180. So 180 minus 37 minus 90 gives us 53 degrees. So that's 53 degrees. CBO is 53 degrees. Okay. And CBA, we're talking about this triangle here. CBA, so we're talking about that angle. We know that and that add up to 180. We know this is the angle. We know this is the angle CBO over here, and we know that's 53 degrees. We know that that angle plus that angle must equal 180, which equals 180. So the angle CBA would equal 180 minus our angle CBO, which is 127 degrees. 127 degrees. Okay, which makes sense because that looks like an obtuse angle. It's greater than 90 degrees. Okay. Now the next part is, that's part A. Part B is find the length of BC. Okay. So BC refers to this length. We'll call that X. With these type of questions, I need to find what I know. Okay. What I know is that I'm going to use the upper triangle, CAB, because I know that this is 60, the tower is 60 meters high. I know that this angle is 12 degrees, and from my calculation I know this angle is 127 degrees, and we're trying to find this length. Okay, so we've essentially almost got our two pairs. We need to work out what that angle is. Okay, so we need to work out what CAB is. So to work out that angle, you'd simply go 180 minus 12 minus 127, 41 degrees. So this is 41 degrees. Okay, so I can now draw my pairs. I'm going to go, alright, with the sine rule I need two pairs. So that's my first pair and that's my second pair. Okay, so let's write, to find the angle BC, we first need to write our equation. So I'll put the x on top. Sine 41 equals, so side on top, then sine 12. I can go interactive and solve to work that out. Okay, so go sine x divided by sine x divided by sine 41 equal, sidestep, equals 60 divided by sine 12. Enter. No, I have to solve it. Interactive event solve for x 189.33. So x equals 189.33. So our BC would equal 189.33 based on that answer. Okay. So our next step is to find the height of the hill, OB. Okay. So we know. Let's draw the triangle again. We've got a right angle here. We know that's CBO. We know CB is 189.33. We know that the angle BCO, we just worked that out. Let's say BCO is given by 37 degrees. And our angle, and we want to work out the height of the hill. We actually don't need to use the sine rule. This is just a normal trig problem because I know what CB equals to and I know what angle we have. We have opposite hypotenuse, so we can use sine. The sine, from SOHCAHTOA, we can use SOC. Sine of 37 degrees equals y, opposite divided by hypotenuse. Free. Solve for y. Let's see what we get. Okay, so solve it. Sine 37 equals x divided by 189.4. Actually, I'm going to try to be really exact, and I'm going to copy down my previous answer. So you can drag and drop your previous answer onto there, so you can make sure it's really accurate. So interactive event solve for x, and I get 113.94. Okay, so my y equals 113.94. So that's my height of the hill in meters. That's the height of hill. Okay, hopefully that helps. Sometimes you don't always have to use a sine rule. You've got to be smart about it. Okay, you can technically use the sine rule and go, all right, this is my first pair and that's my second pair, but you don't need to. Okay, so don't